Now, a question I can ask you at the Chemistry 1 level is to draw a simple 2-central atom or 3-central atom molecule based off a formula that doesn't actually follow the organic notation. So how are you going to figure out how to do this? Well, the trick with drawing things that should have more than one central atom is to identify atoms that typically serve as bridging and atoms that typically serve as terminals. So in the previous video I talked about how fluorine is always a terminal atom, hydrogen is always a terminal atom. Now, carbon is typically a bridging atom. So rarely do we see carbon at the end of an atom, end of a chain. So if we see something like C2F4, this tells us that we have 2 carbons probably constituting a chain. Our fluorines are going to represent the terminals. How do we know where the fluorines go? Well, odds are they're equally distributed among both carbons. There's no reason to believe this asymmetry because, again, this is Chemistry 1 level. We're not expecting you to have a feel for how atoms should be arranging in space. So the easiest thing to do is say that this C2F4 is probably really CF2, CF2. Carbons are going to be your backbone, and they probably each take the fluorines. Now, this carbon here is going to serve as a periphery atom of this carbon and vice versa, but they are part of the backbone. So now that you've gotten this guess, you can start drawing the Lewis structure. So, how do you draw it? Well, you got one method where you do put the electrons around it, connect the dots. There's one where you do the counting. Ultimately, though, you're going to end up with this structure. So if you're asked to find a molecule that has more than one central atom, this typically shows up when you have atoms that typically constitute chains. So you have things like more than one oxygen, or you have more than one carbon. These are probably forming the backbone of some large molecule. The way you draw it is to basically try to assume that it's symmetrically split, half and half. And that's how you draw simple binary molecules.